So the outer covering here of the bundles of muscle fibers, this bundle here is covered by an outer covering which is called a perimysium. And there is a special name we give to each bundle. Each bundle of muscle fibers is called this name here. Is called a fascicle. It is called a fascicle. So if I ask you which of the following is a name given to a bundle of muscle fibers, it is called a fascicle. Remember now, a fascicle is covered by a outer membrane which is called a perimysium. So inside the fascicle, inside the bundle, there are many muscle fibers. Inside the bundle, there are many muscle fibers. And if we pull out a muscle fiber, like we have pulled one here, if we pull out this muscle fiber here, of course this is a muscle fiber, pull it out, it has a outer membrane. It has two membranes. There is this outer membrane which we call the endomysium. So the outer membrane of a muscle fiber is called the endomysium. However, there is a inner membrane. Remember, a muscle fiber is a muscle cell, so it has also a cell membrane. The cell membrane or the inner membrane, this one here, is called the sarcolemma. And then inside the cell, inside the muscle fiber, we have thin thread-like structures which are called the myofibrils. Myofibrils. These myofibrils are made up of actin and myosin filaments. Okay? So if we can recap, a skeletal muscle is attached to bones by tendon. The tendon is continuous on one end with the outer covering of the skeletal muscle, which is called the epimysium. The epimysium encloses many bundles of muscle fibers. So, this is a bundle, this is another bundle, this is another bundle, this is another bundle. All of them are bundles. So each bundle of muscle fibers is called a fascicle. A fascicle, each fascicle is surrounded by a outer membrane which is called the perimysium. Inside the fascicle, inside the bundle, if we pull out one, inside the bundle, there are many muscle fibers. If we pull out one muscle fiber, like this one here, it is composed of two membranes, the muscle fiber. There is the outer membrane. The outer membrane of a muscle fiber is called the endomysium. And then inside the endomysium, there is the usual cell membrane of the muscle fiber, which is called the sarcolemma. The sarcolemma contains small thread-like structures which are called the myofibrils. And myofibrils are composed of actin and myosin filaments. So I've just pulled out one muscle fiber so that you see it clearly. You can see that there are many nuclei. There is one there, there is another nucleus there, there is another one. So we call it multinucleated. Then, of course, it has these striations. You can see some are dark, these ones are dark. Those ones we shall call them the dark bands. The dark bands, we shall look at it. Then there is this one which is white. We call them the light bands rather. We call them the light bands. We shall look at it in details. And then, of course, it has this outer covering, which is called the endomysium. Then the cell membrane. The cell membrane is this one here, the second layer, which we called the sarcolemma. Very good. Then, of course, inside it there, it has many myofibrils. Good. Now, this is just what we have been talking about. So it consists of the outer covering, epimysium. Each of the bundles is called a fascicle. Each fascicle is surrounded by perimysium. Inside the bundle, there are many fibers. Each fiber is surrounded by an outer covering called the endomysium. And inside the endomysium, there is another layer, the cell membrane called the sarcolemma. Then inside the muscle fiber, there are myofibrils. Myofibrils are composed of actin and myosin filaments. That's the general structure of a skeletal muscle. Now, let's look at the fine structure, the most important, the fine structure of a skeletal muscle. Now, before we even start this, I want you to remember these light and dark bands. This one, we say that this one here is a dark band. And then this one, which is looking light, is called a light band. And ask yourself, how is this thing coming about? How is the dark and the light band coming into play? So that is what we are going to answer now in the fine structure. Now, it all starts from the myofibril, from this one. Do you notice that the myofibril here is already having those light and dark bands? You can see the dark band here, and then you can also see the light band here. Do you notice that? That's very good. So let's look at it. So, in the fine structure, we focus so much on the myofibril because it seems to be the one which is bringing in these light and dark bands. So we are saying that each myofibril consists of light band, or what we call the high band, and the dark bands, or what we call the hair bands. So dark band is the same as hair band. Light band is the same as high band. So these two bands, the light and dark, alternate within the myofibril. If I take you back, look at this. So there is a light band here, but it is followed by a dark band. There is a light band, actually up to here, there is a light band. Then it is followed by a what? By a dark band. So the myofibrils consist of those alternating light and dark bands. Now, when you combine the myofibrils together in a muscle fiber, remember myofibrils are contained in a muscle fiber. The myofibrils line in such a way, they lie adjacent to each other in such a way that the lines, the dark lines of one myofibril are in the same line, or lie alongside the dark bands of the next myofibril, so that it forms a continuous dark band. Even the light bands of the myofibrils lie adjacent to each other, so that now it forms a continuous light band in the whole muscle fiber. This is what I mean. Now, remember that this myofibril contains its light bands and dark bands. So if this myofibril, this second one, I'm talking about this is the first one and this is the second one. So if